dimension. Okay, this is aluminum's original dimension. Okay, so this is still our aluminum. Okay, so this is still our reference material. So reference material is aluminum. Okay. However, the N factor over here for Kevlar is 1.792. What does this actually mean? Okay, so this means, I'll sketch this out, okay? So this is, I'm going to make it longer a bit. This is just an approximate. So what this means is now we replace the entire structure to become Kevlar. Sorry, aluminum. Okay, so to replace everything with aluminum, the part that's Kevlar need to be what? Bigger. Yes or no? Right? Okay. So we replace the whole thing now. So for it to carry the same amount of load, right? If we replace Kevlar to aluminum, we have to increase its size. Okay. Now, online, you guys ask question. Yes, yes. Are you clear with how we get N? Yes or no? Not getting a response from you. Okay, good. Okay. Right. Yes. No, this is not physical. Okay. This is how we're going to calculate. Right? This is how we calculate by mathematically putting a coefficient in front. This is what's going on. Okay, good question. So the question asked in physically the aluminum was stretched. My answer is no. This is because we are doing this in a sense in doing the calculation, not physically. Okay. Because the formula that is mz over izz multiplied by y can only be used for one material. It cannot be used for two different materials. So we put a coefficient in front so that we can make it for just one material. That's why we replace the Kevlar with what? Aluminum. In order to replace it, you have to make it bigger, right? Now, one thing I want you all to observe, this is very important. I'll write this down, okay? The width increased, but the height or depth remains the same. So when you see how I sketch this diagram, you only see that the height remain the same, right? So I'm going to show you the height. So the height of the original structure, which I'm drawing orange now, relative to the reference is aluminum. Okay, so the left column and the right figure, so the left and right figure, the height are the same. Are we clear? The only thing that changed is the what? The width. And the reason why is very simple. It's a mathematical change. Why only the width and not the depth? If we calculate the second moment of area, right? So I, ZZ, for example, is equal to the original formula, okay? It's width depth cube divided by 12 plus by width multiplied by depth multiplied by the global centroid minus by the local centroid squared. Okay, this is for a single material. Okay. For a sandwich material, IZZ is equal to N width multiplied by depth cube divided by what? 12 plus by N width multiplied by depth y bar minus small y bar squared. Sandwich material. Okay. So the one for the below one is for the what? Sandwich material. The next reason is why is it like that? Why we cannot? Why don't we increase the depth and make the width what? Constant. The problem is with this equation over here. Depth cube. What is the problem with that equation over there? Let's say now, hypothetically, okay, we allow, I'm going to write on the left-hand side, okay? We allow the height to change. Okay? Let's say now we allow the height to change. What will happen? Right? So now this is NZZ. Width remain the same. Now will be what? N cube, depth cube over what? 12 plus by width and multiplied by depth or height. Y bar minus small y bar squared. Now, this factor over here did not change. It's the same, right? The N multiplied by the W multiplied by D or the N multiplied by D multiplied by W is the same. Yes or no? The difference is this term over here, right? The original, if I write this down, is by right N depth cube over what? 12. Yes or no? When you split it up, the coefficient, the N will be cubed again, and the depth will be cubed. So this is numerically wrong. Okay, not possible. So we are changing width purely because of mathematical reason. Okay, purely just mathematical. Okay, and also to help us simplify our calculation. Are we clear? Okay, so I repeat again, what we learned down here is the width change, the depth did not what? Change. Okay. Anyone, any questions? Face to face or online? Anyone? Yes. Yes, it's a coefficient. Okay, it's like it transpose. If we change everything from Kevlar to aluminum, how much do we need to increase the size? Yes, so that the resistance to stresses are still the same. Right? The resistance of stresses are still the same. Okay. Now let's get back to our example. Yeah, let's get back to our example.
Eugene, someone has a question.
The reason why I replace it with aluminum because I decide to. You can replace it the aluminum to Kevlar. The answer will be the same. Bro, does that make sense to you? Okay, you can choose either material. Does not matter. Okay. So now, thank you for letting me know. Okay, if anyone type a question, just announce to me because I'm writing and the question is on another computer, which I don't usually glance. Thank you. Right. So for this case, there are a few things that we need to do. Okay. So first of all, the thing I'm going to show you, we are going to find a location of the centroid. Okay. Or we have to determine the first thing, find our n value, which we did already. Then location of the centroid. Okay. Determine the second moment of area, and then finally find the maximum stresses of aluminum and Kevlar. Okay. So by looking at the moment vector, yes, I will provide Young's modulus, things like that. Okay, you no need to worry. I will not want you to remember any Young's modulus value at all because I can't. Okay. So by looking at the moment vector, right? So the moment vector, you can see over there the image with a blue curve yellow. We know above the centroid will be compression. Below the centroid will be what? Tensile. Okay. Okay. So here now we already find the n value. We determine now the location of the centroid. So the table that I taught you will change slightly. Okay. So I'm going to draw sketch quickly. This is just a sketch. Okay. So I'll call this our section 1. I'm going to divide it this way. Section 2, 3, and 4. And section 1, I'll just label it as aluminum. I know that is aluminum. Okay. So we're going to find the centroid. So we have section 1, 2, 3, and 4. And I will come back up here. I should have done this earlier, which I did not do. Apologize. I will call this our X.
Hello?
Yes.
Hey man, how's it going?
Yes, I can hear you.
No, it's okay. So I actually got the car, so I'm getting the car next week.
Okay, I know you're getting the car next to you, cheeky sod. I have to mute him now.
Hmm?
Sorry, getting the car next week, okay? And with the price of gas, I'm not so sure about it, okay? Then we have our, yeah, we need some humor a bit, okay? Then the table will change a bit